So next up, before we go ahead with data cleaning, we should check what the type is of data. So for each type, we have to make sure we know the data types properly. And before we go ahead with pre-processing, we have to have an idea about whether it's a, say, categorical, a data type, or a float, like that. So for that, I shall run this cell, and you can see that most of the data types are objects. Maybe there's a problem with what the how with the data that's included, that Google Colab is giving it as an object. And if we check the data set here, we can see all of those are numbers, right? It should be either int or float ideally, but maybe there's a problem that Google Colab is saying that's an object. So so we already figured out a problem with the data set. Let's check if we have missing values included in each of the columns. So we have a straight 0 line, which means we don't have to do any of the pre-processing for the missing values. So now let's check if we have inconsistencies. So we already checked for missing values. We figured out there's a problem with the type of data, and now we'll check the inconsistencies. So that's how we're checking the unique values to see if there's any problem. So with that, I'm printing the variable, so temp average here, and to get the unique values of temp average. So I shall go up and so if you can see, I'll just take two variables and show you what it is like. So when it comes to visibility average miles, this the one that I'm highlighting at the moment, you can see the unique values includes a dash in it, and even the wind average. So here we can see there's a dash. And if we check a few more items, so when it comes to this precipitation, some inches, we can see there's a T. So we have to go through the unique values and figure out what exactly is the problem here. So now we've understood why that Google Colab is taking it as an object. That's because there's a dash and it's not a string or an integer. So that's why it's putting it as an object. So we'll go ahead and figure out how many dashes are there in visibility average miles. So I'm just taking one variable here to show you how to do it. And we are listing the count of the dashes that we have in this particular column, visibility average miles. And also we are taking account of the amount of T's that we have in precipitation. So I'll run this code. We have 12 and 124. So we have 12 dashes in this particular column and 124 T's in this. So we have to actually make sure we replace it with something important, or maybe a 0, before we go ahead with data modeling. So now we are moving on to replacing the dash with a space. So you can see I am taking that data column. So that's data is my data set, and visibility average miles is the column. So I'm replacing that with replaced dashes with spaces. And then I'm printing to see the count of dashes again to find it's 0. So that's all the dashes have been replaced with a space. So now we are going to do the same. We are going to replace the T's with a 0 and convert the entire column to a float. So float is if the column has numerical data with decimal places, we convert it to a float. So now we only used visibility average miles and precipitation sum inches for the data cleaning at the moment. So we'll check how the data types have changed. So you can see that the others, apart from the temperature variables, everything else is still an object, and precipitation sum inches has changed to a float. So the third one, the precipitation, is what we actually changed in terms of the data type. We didn't change the visibility average mass. We just replaced the dashes with spaces. So to continue the process, we are using all the variables here. We are taking all of that in the data set and replacing all the dashes with spaces here. So that's what we do. We can actually, to show you how to do it, I just made everything a single step, but we can use a function where we replace the data point and where we replace the dashes with the spaces. So this is the function that we have. And after my session, there will be a session on modeling. So during that session, our speaker would go through that as well. So this is doing the same thing, but using a function, which is actually more efficient when it comes to coding. And here, the next step is for us to convert all of that, all of the data points that we have, data columns that we have as objects, to convert it to floats, or at least a numeric column. So here we are taking one by one each column and converting it to a numeric column. So I'll just run that. Now we have an entire data set where we don't have dashes and we don't have T's. So now we are checking the data type. So we can see, apart from the temperature ones, everything else is a float. And at the end, we have events, which is still an object variable. So if we go to our data set and actually go to events to check what it is like, you can see this is the events column, the U column. It has a categorical variable. It has rain and thunderstorm here, and then rain, fog, rain, and a lot of missing values. So looks like we can't really do anything using this column. We can either impute it or maybe put another text as NA and use it for the analysis, or we can straight away take it off. So it's up to your call and up to the domain knowledge. How important do we need that column? So this is just to get an idea about the data set, about the cleaned data set, which is here. So we have the count and the mean. So if we are going to impute the missing values, if we didn't have any missing values, so if you're going to impute the missing values, we will need what the mean is by, if you're imputing using mean. So moving on, now you saw that in our data set, we have three of the same type. So temperature, we have a high, average, and low. So when it comes to that, those three variables are generally highly correlated. So that is, say in a certain day, if the temperature high is really high and the low is also high, the average will be in between the low and the high, right? So those three variables are correlated. So if it goes down, all three would go down. And if it goes up, all three would go up. So that is correlation. And we would be checking the correlation of the entire data set by using this data.corr. So that's the correlation code for correlation. So in this, you'll have to go through and see the correlation if it's really high. So I'll just show you the first few ones. So let's go through temp high, average, and low. And the other side, we have temp high, average, and low. So if you see temp high and temp average has a correlation of 0.97, and temp low with temp high has a 0.88. So these are really, really high correlations. And the other way around, it's 9.6. So those are the three main correlations that we have to check. So high with average and low, and average with low. So we can decide that because it's highly correlated, we can drop two of them and just keep one. So if we go with dropping all the high and low variables and just keeping the average of each one of those for our data modeling part of it. So this is another way where we can check the correlation with colors. So this is a relatively colorful correlation matrix compared to what we checked earlier. It was just the numbers. So as you can see, the summary, we have the temp high and temp high at this side. So all the red ones, it's mainly more than 0.75. So you can see we have boxes of nines a lot. So that's because we have these three variables coming into play. So in each of the main variables, we're going to take off the high and the low and just go ahead with the analysis using averages. So to go ahead with the cleaning part of the last point of cleaning is data reduction. So we are taking off highly correlated variables and reducing the data set to the variables that we think would be very useful. So here we are taking a selected set of columns from the data set. So you can see I'm using all the averages, humidity, average percentage, sea level pressure, average, all of that is averages that I'm taking. And I'll just run the code. So you can see all the high and the low variables have dropped out and we have all the averages here. So from this point onwards, we will be going ahead with the modeling part. So this is pretty much the pre-processing side of the Austin weather dataset. There can be so many other ways of dealing with the same dataset, but this is what we went ahead with for this session. So with that, I would be stopping my session, but we'll go for questions now.